changes in atmospheric composition that humans are causing. And after about 5 years, we had some results that we thought were significant. For one thing, and we wrote this article that was published in Science magazine, which reported that the temperature of Earth had increased about 0.4 degrees Celsius over the previous century, and which was consistent with what was calculated as an expected global temperature change, given the change in atmospheric carbon dioxide that had occurred over that period. We also concluded that the 1980s should be the warmest decade in the history of instrumental measurements, and by the 1990s, the warming should be large enough to rise above the level of natural variability, or rise out of the noise level of temperature change. And in the 21st century, we argued that there would be the creation of drought-prone regions in North America and Asia, beginning of melting of the ice sheets and rising sea level, and opening of the fabled Northwest Passage. All of these things have since occurred. That paper was reported on the front page of the New York Times by Walter Sullivan, the science writer for the New York Times. And so, as a result, I received these requests to testify to Congress, which I did several times during the 1980s. And the 1988 testimony, as was mentioned a few minutes ago, got quite a lot of attention because that was the year of extreme drought and heat waves in the United States. And but I realized that my testimony then, there was a danger that it was misunderstood because of the emphasis on the drought. What we understand is that as the planet gets warmer, it increases the extremes of both ends of the hydrologic cycle. So because a warmer atmosphere holds more water vapor, that means that when you do get rain, at the times and places when you do get rain, you will get heavier rains. You can get much heavier rains and greater floods. So it increases both extremes of the hydrologic cycle. So I wanted to testify once more, and I did testify in 1989, a different Senate hearing, and that. So the science got a bit obscured because the day before my testimony, I told Senator Gore that my testimony had been changed by the White House. And I wanted him to ask me about certain lines in the testimony because I was going to say those were written by OMB, not by me. So anyway, then that caused a lot of hoopla, and the science tended to get lost in that. But contrary to what we just heard, I felt, and I decided at that time that I did not want to continue to speak out about this issue because I'm not a good public speaker, and I think I can do science pretty well, and so I decided I should spend my time on science. And there are other scientists, like my friend Steve Schneider was a student when I was a postdoc at Columbia, and he's a very good speaker, and he likes to do it. So I would refer media requests to him, and sometimes Michael Oppenheimer, who also is very articulate. And so for 15 years, I actually avoided. I did not take requests for television interviews in that period. But finally, well, actually my first grandchild, Sophie, was born just before the end of the century. But the reason I used this photo, I showed this photo in a science talk at Lamont Geophysical Observatory because the prior day I had been called in a newspaper article the grandfather of global warming. Which is, of course, not true. Global warming has been, the fundamentals have been known for a long time. The most impressive early work, I think, was by John Tyndall, who was a British physicist in the 1850s, actually Irish, but he did the laboratory measurements on carbon dioxide that showed that CO2 absorbs heat radiation. And therefore, when you add more of it to the atmosphere, you will reduce heat radiation from the Earth to space, and that causes the planet to be absorbing more energy than it radiates, so it has to get warmer to reestablish equilibrium. And he also inferred correctly that the interglacial cycles that the Earth was known to have gone through involved CO2 changes as a principal mechanism for causing those temperature changes. So, but my point was that at least I was a grandfather. And still, so then I had the opportunity early in the Bush administration to speak to the President's Climate and Energy Task Force, which was chaired by the Vice President Cheney, and included 6 cabinet members and the National Security Advisor, Condoleezza Rice, and the EPA administrator. In fact, I spoke to them twice. I was the only scientist that got to speak with them twice, but still, we did not have an impact on the policies. In fact, Vice President Cheney's idea was to build 1,000 new coal-fired power plants. So I was asked in 2004, I was asked to give a talk at a Democratic fundraiser, and I declined to do that because I'm not a Democrat, I'm independent, and I prefer not to get involved in politics. But I said that I wanted to give a public talk because it had become clear by this time that we really were running out of time. And so I decided that I wanted to argue that we would be better off if we elected John Kerry rather than President Bush, re-elect President Bush. So there was a plan that I was to give a talk at the National Press Club, and I worked 6 months preparing for that and a scientific paper to go along with it. But then when it came time, I said I was ready to give the talk, then the organization that was sponsoring it changed their mind. So I ended up calling Professor Van Allen at the University of Iowa, and he arranged for a distinguished lecture at the University of Iowa, so-called distinguished lecture, which, of course, does not get that much attention. But the next year, I was asked by Ralph Keeling, the son of Dave Keeling, to give a talk at the AGU meeting in honor of his father who had died that year. And so I gave essentially the talk again that I'd given in Iowa, in which I used my 2 grandchildren at that time, Sophie and Connor, to help explain how. So I still was only using my grandchildren as a prompt to help me explain this, how global warming works. as Sophie was saying, the net effect is a heating of the earth at about 2 watts per meter squared, but Connor could only count 1 watt. And the truth is, because we're not measuring aerosol, we don't know the net forcing very accurately. And it's someplace in that range. But in any case, that talk did get the attention of the White House, and there were at least 2 telephone calls from the White House to NASA headquarters complaining about my talk. And so NASA Public Affairs decided that there should be a new policy, and I would not be allowed to speak to the media unless it was approved prior by NASA headquarters, and they could substitute somebody else for me if they preferred when the media asked to speak to me. So after this had gone on for a few weeks and some requests had been redirected to other scientists to answer, then I told the New York Times about that. And the policy then was changed. But unfortunately, though, it's not that simple, even though, we live in a democracy, but the way things work is not so simple. And there were consequences of that. So within a few weeks, in the middle of the night, first of all, the first line of the NASA mission statement disappeared to understand and protect the home planet. And secondly, the research and analysis budget was reduced 30% retroactively to the beginning of the year. Somewhat thereafter, I got another grandchild, my son's first child, and I forgot why I put that photo in there. Except to say, well, yeah, so the point was, when I was asked on 60 Minutes why I was speaking out, I said, well, I didn't want my grandchildren to say Opa understood what was happening, but he didn't make it clear. And beginning in, I think it was 2006, I began to give a few talks. I thought that although it didn't seem possible to influence the policies in the current administration, that there were other countries where I might persuade them about what's really needed. What I found, though, in visiting 10 or 12 countries was it's really not much different in other countries. Even though we have the impression that some countries are very green, it turns out that their policies are very heavily influenced by the fossil fuel industry. And I can give examples of that, but the fact is that the CO2 emissions just continue to accelerate. And actually the rate of growth has actually increased in the last decade from the prior few decades. And so the status is that there's this gap between what is understood about global warming by the relevant scientific community and what's known by the public. And the truth is, we do have a crisis, because the reason that can be, even though you don't notice that much happening yet, is the inertia of the climate system. The ocean is 4 kilometers deep, the ice sheets are a few kilometers thick, so they don't respond quickly to the forcings that we're applying to the system. And as a result, we've only realized part of the warming due to the gases that are already in the atmosphere. And there's the danger that we can push the system past tipping points where future changes will occur that are essentially out of control of humanity. And for example, ice sheet disintegration. As the ocean gets warmer, it's going to stay warm for centuries. And that will allow the ice shelves to begin to melt. They are beginning to melt. And that allows the ice streams to discharge ice to the ocean much more rapidly. You can get to a point where the ice sheet would disintegrate rapidly and we get large sea level rise. And likewise, another nonlinear problem where things can begin to change rapidly is species extermination, because we're putting pressure on different species in many different ways, and if we add to that rapidly shifting climate zones, then we can begin to drive some species to extinction, and then because of their interdependencies we could end up losing a large fraction of the species on the planet. So the temperature is rising, and you hear recently that, oh, global warming has stopped. That's based on, that comment is based on the fact that 1998 was a very warm year. It had the El Nino of the century, so the temperature jumped 2 standard deviations above the trend line. But the warmest year is actually 2010, and 2005 is the second warmest year. And if you average the temperature over 11 years, which is the solar cycle, then you get that blue curve, and you see that on the decadal time scale, the temperature is still going up. And that's all that we expect, given the effect of greenhouse gases. You're going to get fluctuations, but we know that this decade is going to be warmer than the last one, and next decade is going to be warmer than this one. The reason we know that is the planet is out of energy balance because of the increasing greenhouse gases. There's more energy coming in than going out, and we can now measure that because of the Argo floats that began to be distributed around the world's ocean about a decade ago. We can now measure, because most of the energy, excess energy, has to be going into the ocean because the atmosphere has a very small heat capacity. So the ocean is warming up. We can now measure these floats, dive down to a depth of 2 kilometers, and then they go back to the surface where they radio their measurements to a satellite. What we find is that indeed the ocean's heat content is continuing to increase. So that's a measure of how far the planet is out of energy balance. And those measurements were made during the deepest and longest solar minimum in the period of accurate measurements of the sun. The brightness of the sun does vary with time, and we are we just experienced the deepest solar minimum in this period, and the current solar maximum is very weak. It's only about half as strong as the 3 prior solar maxima. So that's one of the natural factors that changes climate. But this forcing is about 1/10 of a watt reduction on the average from the prior decade. So it's a smaller effect than the increasing CO2, which is about 3/10 of a watt per meter squared. And we see that things are beginning to change. The sea ice in the Arctic last summer, the minimum at the end of the melt season was only 51% as much sea ice as 30 years ago. And the thickness of the ice was only half as much. So 3/4 of the volume is lost. Now that will fluctuate from year to year. This summer, there's more sea ice than there was so far than there was last summer. But that's just the way it depends on the weather that particular summer. Similarly, in the case of the melting on the Greenland ice sheet, you can see from the line graph that it fluctuates a lot from year to year. But overall, there's a trend toward getting larger areas on Greenland with summer melt. And that meltwater will go to the low spot on the ice sheet where it burrows a hole in the ice sheet and goes all the way to the base of the ice sheet. It lubricates it and speeds up the discharge of giant icebergs to the ocean. And that's affecting the mass balance of the ice sheets. We can now measure the mass of the Greenland and Antarctic ice sheets with the gravity satellite, which measures the gravitational field so accurately that you can see changes in the mass. And the ice sheets get heavier in the winter as the snow falls, but they lose mass in the melting season, and overall they're losing mass at a faster and faster rate. Now, the most recent data for Greenland last year, it had its biggest mass loss, which was 500 cubic kilometers of ice, which is still not, the sea level is now going up 3.2 millimeters a year, which is 32 centimeters or more than a foot per century. That's still, which is not negligible, but it's not a disaster. But the rates are accelerating, and that's the danger. That if we stay on business as usual, I think we will get multi-meter sea level rise during this century. The other, and that's of course an irreversible effect. If we let that happen, it takes thousands of years, tens of thousands of years for an ice sheet to build up and restore sea level. So we don't want to have multi-meter sea level rise. The economic implications of that would be incredible, since we have many cities on coastlines all around the world. The other thing is the impact on all the different species. And I like to use the monarch butterfly as an example because it's a good example, and then we're putting, as with other species, we're putting stresses on it for other reasons than climate change. But it's the combination of those stresses plus climate change which is important. And I plant, with my grandchildren, we plant milkweeds to try to help the monarch butterfly, which is being stressed by Roundup, which is a chemical that farmers use to kill weeds, but it kills milkweeds. And milkweeds are the only thing that the larva of monarch can eat. So, yeah, this is an amazing species. It migrates all the way from Canada to this small mountain area in Mexico where it hibernates for the winter. And it takes about 4 generations to make this cycle, this annual migration. They lay eggs on milkweed plant, and the next monarch is somehow able to know that it's got to fly to that mountain in Mexico. Even if they get blown off course 1,000 kilometers, they still know they've got to get to that mountain. This particular summer, when my wife and I were younger, we would notice in our small piece of land in Pennsylvania, we could see 10 or 12 monarchs at once. Now you may see one or two. But in this particular summer, I noticed this one. I could identify this one because it had broken wing. This is a female with a broken wing. And she hung around for a few weeks. I actually that was the time that I came down to my sister's house. There was a hurricane. It wasn't a hurricane by the time it got here in Pennsylvania, but it was a very strong storm. It dumped 8 inches of rain on our property and high winds. So I thought, when I get back home, those larvae would be washed away, and I don't know. I wouldn't see how a butterfly could withstand an 8-inch rain But that same butterfly was still flitting about our yard, and we just had one butterfly. And she produced more than about 20 butterflies. This was a male that she produced, and this is a female. But we were wondering how many of those butterflies would make it to this mountain in Mexico, because they had to go through Texas, which was having an extreme drought in 2011. And in fact, the number that made it was reduced 30%. Now, I wrote an article about that, and a scientist in Mexico who's studying the mountain sent me some photos that he had taken. These are butterflies that made it to the pine trees that they hibernate on. And this is his son looking up at them. But what he sees is that the tops of the trees are really stressed because of the climate change. The climate zones are shifting, so they get more drought there. And so that scientist is trying to persuade the Mexican government to plant these trees higher up the mountain where the climate is more appropriate. And by the way, so then this last year, we had even worse drought, a bigger area under drought, and the number of monarchs was reduced 50% more. So that the number making it is only, the number of monarchs is now about 7% of what it was a few decades ago. So anyway, that's one species. But coral reefs are under stress for several reasons. The acidification of the ocean and the warming of the ocean, which causes bleaching of the coral. They expel their symbiotic algae and die. And there's more than 1 million species that are associated with coral reefs. So it's potentially a big problem if we stay on business as usual and allow the ocean to get more and more acid. Now there are, in addition to these irreversible possible effects, we can see that climate is changing. The distribution of temperature anomalies, summer temperature anomalies. In summer, the climate is less variable than it is in winter, so we can begin to see the effects more easily. And the bell curve that describes the distribution of anomalies about the long-term average is now shifting toward warmer temperatures because of global warming. And so the kind of extreme events that occurred only a few tenths of 1% of the time last century now are occurring much more frequently. And that's, or you can say there are larger areas that are covered by extreme events in the summer. And those extreme warm events will tend to be in those places where you have high pressure, given the weather patterns that you have, and they fluctuate from year to year. But the places where you have high pressure, you tend to get extreme drought and heat waves. And that does affect, for one thing, the amount and the intensity of the fires, which burn hotter and are more damaging. And we can see that these are occurring more frequently over wider areas. But in addition, as I say, the other extreme of the hydrologic cycle also increases. So you can get 100-year floods that are now occurring more than once every century. And there is an impact of this warming on the potential strength of storms that are driven by latent heat. That means thunderstorms, tornadoes, and tropical storms, which get their strength from water vapor, from latent heat, can be stronger. And in the case of this Christie, this hurricane last year, the waters along the east coast of the United States were a few degrees warmer than normal, so it was able to stay Category 1 hurricane all the way up to New York. And then it combined with a frontal storm, so it moved into the country and had strength all the way across the eastern part of the country, and caused a lot of damage in the coastal areas, and especially in the New York area. So the politicians did finally begin to notice. Thanks in part to Mayor Bloomberg, who didn't allow them to completely ignore the fact that humans are beginning to affect the climate. But he still did not really talk about the fundamental issues. We have burned only a small fraction of the total fossil fuels in the ground. We've burned the purple parts of the conventional oil, gas, and coal. So what is clear, and we're already getting close to the limit of how much we should burn, because there's additional warming that's in the pipeline, which is going to occur in the future, even without any additional increases in atmospheric greenhouse gases. So it's clear we can't burn all of the coal or the unconventional gases, unconventional fossil fuels, without guaranteeing that our children and grandchildren will have a situation that's out of their control. So we could still stabilize climate, but only if we phase out coal emissions and leave the unconventional fossil fuels in the ground. Now, how to get that to happen? Well, what's really happening, of course, is that we're allowing and even subsidizing fossil fuel companies to go after every fossil fuel they can find. So, now Jake has severe peanut allergies, but he thinks, here he is with his 2.5-day-old baby sister, who he thinks he can protect. But the truth is, it's really up to us, not a 2.5-year-old with peanut allergies, to solve the problem. It's a matter of intergenerational justice. You know, our parents did not know that their actions could harm future generations, but we can only pretend that we didn't know, because the science has become crystal clear. This is, and by the way, I'm sorry to say, but I'm slightly have more than my fair share. My daughter has a third child, and this is Connor, the little fat boy in the first chart, with his baby brother Eric. So I now have 5 grandchildren. But and so what can we do about that? Well, one thing we can do is try to influence the political process. So here's my oldest grandchild writing a letter to President Obama. And she's pretty confident that I'm going to like what she writes. Because, among other things, she says, "Why don't you listen to my grandfather?" This is a strange situation, because every culture that we know of really feels an obligation to their children and tries to do the best for their children. And our founding fathers recognized that we have a duty to leave for our children a planet that's in equally good condition to the one that we received. Unfortunately, governments seem to think that they can just do whatever they please. And so it's up to the public to get involved. And one thing we can do is try to take the government to court. And I'm spending a fair amount of time providing the scientific basis for legal cases to try to have the courts ask the government for a plan. What are you going to do to assure the rights of young people? But courts seldom get far out in front of public opinion. So even in the case of civil rights, it wasn't until people were getting concerned, were marching in the streets and things, that the courts finally did require governments to give a plan for desegregated schools, for example. So the problem is, the fundamental problem is that as long as fossil fuels are the cheapest energy, or appear to be the cheapest energy to the public, then somebody's going to keep burning them. Even if you take some actions to reduce emissions with whatever way, all that does is reduce the demand and therefore the price, and therefore somebody else will burn the fuel. But the fuels are not really cheapest. If they weren't subsidized, and if they had to pay for the human health costs of the air and water pollution, and if they had to pay for the climate costs, then we could begin to move on to clean energies. So the thing that I think is absolutely essential is that we put a fee on fossil fuels, on carbon that you should collect from the fossil fuel companies at the source, at the domestic mine or the port of entry, so that it covers everything. And that fee should gradually rise over time, so that and the public and business people should know that it's going to rise, so that they would take account of that in making their plans and making their investments and in encouraging innovations. And furthermore, that money has to be given to the public. Otherwise, the public is never going to accept a rising carbon fee. And furthermore, they need to have the money in order to make the adjustments to their lifestyle. This kind of approach would be transparent, market-based, and stimulate innovation, and it would not enlarge the government. And it leaves the energy choices to the individuals and free competition. So this is a conservative energy and climate plan. And it's just very fundamental. If you don't have something with those characteristics, I don't see how we can solve the problem. And this has the merit not only of stimulating the economy and dealing with our fossil fuel addiction, but it has the potential to be international, because frankly it only requires that China and the United States agree to have a bilateral agreement. We will not, on any time scale that's useful, get an international agreement with 180 nations. That UN process is simply not going to work. But it does require an international. It just requires China and the U.S., and frankly, that means the U.S. China is ready now to put a carbon price on it. So that's why what you are doing is so crucial. It's not going to be easy, given the power that fossil fuel industry has over our political process. But it's what has to be done. And so, and we're getting closer than you think. There are now conservatives who are beginning to understand that if they continue to pretend that climate change is a hoax, that the public will reasonably at some point realize that the hoax, that it was not a hoax, and that public will demand that something be done, and that means government takes over, which is the worst nightmare of a conservative. So they would much rather deal with the problem in an honest way and do it in a way which is consistent with conservative principles. And I think most Americans, once they understand this, would be very supportive. But it's not so easy to get everybody to understand the situation when you've got a fossil fuel industry making a lot of money off the current system. As far as getting an international agreement, if China and the U.S. would agree, and if they would put a border duty on products from countries that don't have a carbon fee, that would be a great incentive for other countries to have an equivalent carbon fee, so they could collect the money rather than have us collect it at our borders. Now, it's not to underestimate how difficult. Most of our energy, and the U.S. is fairly representative of the world, but most of our energy is coming from fossil fuels. The big difference with the rest of the world is that coal provides about 35% of the energy for the world as a whole, as opposed to 20% in the U.S. But emissions can be decreased rapidly. There are different ways to do that. France, in a 10-year period, went from 8% of its electricity being nuclear to 70%. Germany is a very different approach. They don't like nuclear, so they're making a very strong effort to go renewable. 2011 they were up to 19%. 2012 I think it's 22%. So changes can be rapid, but they're only going to be rapid and global if we have an honest price on emissions. And I had, that's how I usually end my talks, by giving your contact information. I think I probably used all of my time, but I wanted to say one more thing. And I made a chart yesterday. I'm writing something. I spent a week in Europe recently trying to persuade. I went from Brussels to The Hague to Berlin to London and to Paris to speak with government officials in all these capitals, to try to persuade them to put an appropriate tax on tar sands oil. Somehow the Canadian government found out about this. We were shadowed by Canadian officials trying to persuade, trying to discount what we were saying. Sorry. By at least a 10-to-1 margin, the emails that I get from Canada are very positive, and they're apologizing for it. But you know, even in Alberta now, so the current government in Canada is strongly controlled by the fossil fuel industry, and it's actually a minority government in the sense that they're, I think, 30-some% supported the winning party. But even in Alberta, I went to Edmonton and Calgary to testify, this was a few years ago, against expansion of the tar sands. And I found that the people there were very friendly. And actually, even though you know, it was really stacked against us. The group that was reviewing whether they would approve this expansion really didn't have much choice. But I happened to, one of the people on that board ran into me in the street, stopped me and just said he wanted to shake my hand. Now, but at the same time, they voted to expand. Because that's just the way the politics there is going. But it's not, you know, we have to get them to understand. We have to influence the system the way you're trying to do it. And I had wanted to say something about the simplified. Anyway, I'm writing something for my email distribution. So last night I only spent 3 hours. I don't remember exactly what I was going to say about this. So look for my next email distribution. The point that I want to make is that we have to make sure that the policies that the governments are pushed toward are ones that will actually solve the problem. You know, and that requires a price on carbon. And it has to be a method that works. And it has to be a method which is going to cause the unconventional fossil fuels and coal, most of the remaining coal, to be left in the ground. And the thing that will do that is a gradually rising price on carbon. Because then you will reach tipping points where alternatives are cheaper, and then you get a rapid movement toward those alternatives. And without that, you can't do it by regulations. You've got to actually encourage the development of the clean energies in a way, and it will only happen if they're economically competitive. And I want to stop because the next speaker can explain this much better than I can. So I think I must stop.
What are you doing? Dr. Hansen questions? Is that what's happening? Dr. Hansen, can you take a couple of questions? Can you take a couple of questions, Dr. Hansen? All right. Okay.